Welcome back. In this video, we're going to see how to solve quadratic equations using the zero product property. Let's take a look at a problem that arises in this context. Here we read the entire problem statement real slowly for ourselves, word by word. Problem 5, use the zero product property to solve x squared equals negative 2x. We have formed a good habit of asking every time we see a math statement, is there an equals sign? In this case, there is. We know immediately the entire thing is an equation, and we are going to solve that equation. We might also ask, what type of equation is this? Here we see a square power, and we know from our acumen using the Spanish language, square is cuadro. Este es un cuadro. This is a square. This must be a quadratic equation. If we want to solve this using an algebraic technique, we need to be able to undo the square. We haven't really talked about what the inverse operation of a second power is. One way we will solve quadratic equations in this class is to use the zero product property. When we see quadratics, we might think zero product property. In order to apply the zero product property, we need to take the original equation that we're given and get one side equal to 0. In this case, I'm going to get the negative 2x over to the other side by inverting subtraction. I know that negative 2x plus 2x is 0. X squared and 2x are non-common terms. This is a squared term. That's just an x. The left-hand side is then written as x squared plus 2x. I cannot combine like terms. We see that we've done the first of the two things we needed to finish in order to apply the zero product property, which is we've gotten the right-hand side equal to 0. This side is not yet a product, but we know that we can try to factor it, as discussed before. The x squared we could write as x times x. The 2x we could write as 2 times x. And notice these two terms share a factor of x. In other words, this is x times x plus 2 equal to 0. We see in this situation, this is the exact form that we expect if we're going to apply the zero product property. A factor times another factor equals 0. We know immediately from the zero product property, either our first factor is equal to 0 or our second factor is equal to 0. In the case that our second factor is equal to 0, I get the x by itself by just bringing the 2 over to the other side. Inverse of addition is subtraction. And we have two options for our solutions. We have not finished this problem yet because we haven't checked our work. In order to check, we substitute the proposed value of our solution back into the original equation. In this case, we see that everywhere we see a x, we're going to substitute 0. We're not sure whether or not this is true. 0 squared is 0. Negative 2 times 0 is 0. Indeed, x equals 0 creates a true statement. This is a solution. Let's take a look at our other guess here. Everywhere we see an x in the original equation, we're going to substitute the value negative 2. In this case, we see negative 2 squared. We want to know, is that equal to negative 2 times negative 2? In fact, negative 2 squared is 4. Negative 2 times negative 2 is 4. That is also a true statement, which means these are two solutions to that equation. Looking back, we approached a quadratic equation. We knew it was quadratic because there was a square. We don't yet in this class know how to undo the square power. We might think if we see a quadratic equation, one option that we have is to apply the zero product property. In order to do so, I need to get my right-hand side equal to 0. I did that by bringing one term over to the other side. This is not yet written as a product, even though we have 0 on the right-hand side. So we do this really, really famous thing called factoring. Once we have a factored form of the left-hand side equal to 0, I apply the inverse operation. This multiplication disappears. I solve each linear equation associated with that, check my work, and I get my two solutions. Let's resolve this problem graphically and see that we get the same answer out.